Hello and welcome back. Today we're going to cover how to factor trinomials. Trinomials are polynomials with three terms. So we can see x squared plus 7x plus 12. We're going to use the sum product rule, meaning we're looking at the coefficient of x and we're looking at the constant. And we want to find two numbers that multiply, or the product is 12, and the sum they add together to make 7. So playing with those factors, well, we know that 12 can be 2 and 6, but that doesn't add up to 7. Another pair of factors of 12, 1 and 12, that doesn't add up to 7 either. The next set, 3 and 4, well, that does add up to 7. So the product of 3 and 4, or 3 times 4 is 12, and 3 plus 4 equals 7. Now, I'm going to practice factoring this by grouping. So when I split up the 7x into 3x and 4x, well, now I can use grouping. So this is factoring by decomposition. Now remember, with grouping, we look at the first two terms, find the GCF, look at the next two terms, find that GCF, and then we factor out the binomial. And whatever is left over is the second factor. I practiced showing you with the decomposition, just so when we get to difficult problems, it's a little bit easier. But after a while, I know for sure that you're going to go from this step straight down and bypass the grouping, because you can see right away that the factors 3 and 4, positive 3 and positive 4, are exactly what's after the x. Now these are the types of problems that you can get correct every single time, because you can FOIL it to make sure that you get it back to the same answer. Now let's look at a problem that has a coefficient in front, or number in front of x squared, a leading coefficient that is not 1. So if you notice, this one had a coefficient of 1. So we're looking at factors of 12. So when we have a 2, we have to take that into account, because the product is really going to be A times C. So when I look at A, we have 2. And our C is -3. So A times C, or 2 times -3, is -6. So we're going to look at -6, and we want factors of -6 that add to make -5. So factors of -6 that add to make a -5, well, if we tried -2 and 3, that wouldn't work. But if you tried -6 and +1, that would work. Now be careful, because these numbers are a little bit tricky, because remember, this leading coefficient was 2. So I'm going to split up -5x, and I'm going to factor by grouping, factoring by decomposition, by separating this into -6x plus x minus 3. Now looking at the first two terms, the GCF is going to be 2x. And we're left with x minus 3. Well, there's no common factor except for 1 with x minus 3. So if we factor out a plus 1, we'll have x minus 3 as the binomial. So this factors into 2x plus 1 and x minus 3. So I just want you to be really careful, because unlike the first example where the 4 and the 3 were evident in the factors, this -6 and the 1 is not. The -6 is the factor or the product of 2 times -3. Okay, so you can play around with combinations, and I like to show the work with my X method. Okay, now let's go to example 2. In this graph, we have the function x squared plus 2x minus 8. Right, you can see the y-intercept, minus 8, down here. And then you can also see the 2 zeros. 1 0, or an x-intercept, is -4, 0. And then the second one, 2 0, is the second y-intercept. And we call it a 0 because that's when y equals 0. But we also can call it an x-intercept since we have the coordinates. All right, so if we know that the 0 is -4, and we know the second factor, or 0 I should say, is 2, then if I set them equal to 0, if I add the 4, I'll get x plus 4 equals 0, and x minus 2 equals 0. So these zeros right here on the first line actually tell us the factors of the equation. So the factors of the equation, well, it's a little tricky, but I'm going to write it out. Okay, so the factors, it's going to be x minus the first root times x minus the second, right, because I have 0. So I'm going to write this out. So y equals, well, we don't know our a yet, but we do know x plus 4 and x minus 2, right? Because those were from the zeros, x plus 4 and x minus 2. We know a little bit more about the graph. We know that it opens up, so we know that a is going to be positive, but we don't know the exact number. So we need one more point. We need something to plug in for x and something to plug in for y. So we do have a point here, right? On the graph, we have the y-intercept, which is 0, -8. So if I plug 0 in for x and -8 in for y, I can get and figure out what a equals. So I'm going to plug in 0, and you can see really clearly that it's going to be a times 4 times -2. So a is in fact 1. So if a equals 1, then we know that this equation has to be x plus 4 and x minus 2. If we FOIL it out, we'll get x squared plus 4x minus 2x minus 8. And that brings us back to x squared plus 2x minus 8. And that was the original equation, right? So we knew that the original equation's up here. So why all this work? Well, we're showing that when you have the zeros, right here, here's the zeros. I'm going to use a different color. You have the zeros, and these are the zeros. Then you can figure out the factors. And here are the factors. And the factors tell us the equation. and we want to know what the equation is, right? So that gives us the equation up there, and here's the equation. Again, we are able to figure it out with the graph. Okay, now let's go to the zero product property. Since we know that the zeros is when y equals 0, we can figure out the zeros using the zero product property. That means that we set each factor equal to 0. So there's a couple steps. The first is that you want to set it equal to 0. When we're solving, we're going to set the equation equal to 0. And then our second step is where we're going to factor. Whenever we can, we're going to try to factor. And then our third step is to set each factor equal to 0. I'm just going to write the equal sign. And this is how we find the zeros. And that's what it means to solve. We're saying, what are those x-intercepts? When will the graph touch the x-axis? Okay, so let's look at the first one. You can see it's equal to 42. So to make it equal to 0, we're going to have to subtract 42. Now, if we're looking at 42, and this has a coefficient of 1, we know we want two numbers that add to make 1 and multiply to make negative 42. So that'll be negative 7 and positive 6. Remember we talked about that shortcut, that when you factor a trinomial with a leading coefficient of 1, this is going to factor into x minus 7, x plus 6. And we can double check that by foiling this out. Our second step was to factor, and our third step was to set each factor equal to 0. So our solutions, when we solve it, we'll have two answers because this parabola has two x-intercepts. The zeros are x equals 7 and x equals negative 3. Now for the last one here for today, we're going to have to set this equal to 0. So I'll add 9x to both sides and subtract 5. I try to keep the number in front of x squared positive, but you can do it the other way as well. Okay, so for this one, I'm looking at two numbers. I'm trying to find two numbers that multiply to make negative 10 and add to make positive 9. So that's going to be positive 10 and negative 1. For this one, remember, we're going to use decomposition, factoring by grouping, because the coefficient wasn't 1. It was anything but 1. So this one had a 2. Now looking at the first two terms, the GCF is 2x. So that factors into x plus 5. Looking at the next two terms, the only thing I can take out is negative 1, because in the parentheses I want to have an x plus 5. Well, factor by grouping, we get 2x minus 1 and x plus 5. Now we've finished our second step. Our third step was to set each of these factors equal to 0. So 2x minus 1 equals 0, and x plus 5 equals 0. So when I solve for x on this side, I add 1 to both sides and divide by 2. And for the next one, I'm just going to subtract 5. So my two answers, my two x-intercepts, right? The two zeros would be 1/2 and negative 5. I hope this lesson was useful, and thank you for joining me today.